Hello, my CNC brother or sister. I'm Garrett, CEO of IDC Woodcraft, the company that provides you with your CNC router bits. If you're in the market for CNC router and you're looking at some of the different companies like Onefinity, MillRight, and Longmill and other machines, but you're still not sure about the company behind it and about the machines themselves, well, you're going to find this video very interesting. This video is a dialogue between myself and a guy named Andy Lee. He is one of the owners of a company called CNC Labs. CNC Labs is not only the developer of a CNC router series like the Longmill MK2 and other CNC machines and a CO2 laser and CNC software, but they're also innovators in the CNC industry, always coming up with new product. Whether you're in the market for a machine and want to know more about the Longmill series, Altmill series type of CNC machines, or are just interested in some of the innovations that are coming along in the CNC industry, then this video is going to be something that's going to enlighten you in both fronts. So grab a cup of coffee, sit back, and enjoy this dialogue and learn what's going on in the CNC world and maybe help you make a decision on the machine that you want to get. Enjoy. IDCwoodcraft.com. So let's do a little 5-minute. What are you guys working on? You're working on a new router, new trim router type of deal. You've got the Altmill CO2 laser. You've developed the Super Longboard. And so explain, first of all, let's talk about the Super Longboard, because I know there's a couple of questions in there about that.
Sure.
And what is it over what you have for the long mill or whatever machines you got, and what was the intention behind it? What is it capable of that your current control systems are not?
Right. So the Super Longboard is essentially our successor to the Longboard, which is the control board that runs the long mill. And throughout working with the Longboard, there was a couple of things that we wanted to iron out in terms of what the board could do, and I guess future-proofing it for the long mill as it moves forward and using the technology for other products. Mm-hmm. So the first most important thing that we wanted to address with the Super Longboard was connect like the reliability of the connection. So one of the things that kind of plagues all hobby CNC machines is they can disconnect. And the the Longboard is not this. There's no it's not an exception to that. And there's a number of reasons why controllers disconnect. One is interference. So sometimes if there's like an electrical signal induced through the cable, that can throw off a controller, and controller's like, hey, I don't know what's going on. Can be a physical thing. So the cable connection might not be secure, and so that might kind of like jostle out of place. And also, what else is there? Yeah, and the connection. One of the things in the board itself was like we had an Arduino attached to the board itself, and that connection wasn't like the most secure either. There's like a number of like smaller things, but overall, the connectivity part was a big thing.
Okay. So for those of you who are wondering what we're talking about, so this is, first of all, for those who have popped in, we were talking to Andy Lee from CNC Labs. They are the company that has developed the Longmill CNC router. They've just come out with the Altmill. They're developing a CO2 laser. So it'd be like one of the first CO2 lasers built in the United States, designed and built in the US. That's like, what's that?
It'll be built in Canada.
Canada, North America is what I meant. Yeah. Well, so I always view Canada. Sorry, I slipped out. I always view Canada as like our brother, right?
Yeah, exactly.
Yeah. So anyway, North America is what I meant. So which is the almost all the CO2 lasers you get that come out of China. My Mon port is out of China. All right, and so they're just actually there's only 3 companies in China that make CO2 lasers, and so the companies buy them and brand them with their brand, and then they resell them. So Monport is one of those. Tech is another one. It's the Omtech and the Monport are the exact same machines. And what you have is a price difference, a pretty significant price difference. Anyway, so that's very exciting. Anyway, go ahead. I interrupted you.
Yeah. So that was the first thing. Reliability of connection is first thing. The second is like performance. We use TB6600 drivers on the old controller, and one of the inherent flaws of the driver is it's not able to resist the resonance that happens above 4,000 millimeters per minute. So as we were able to improve the machine and also improve the system that keeps the lead screws together, we wanted to push the machine faster. But torque isn't as big of an issue, but it's the resonance. So we need to use more advanced drivers that can regulate the current and the signal going to the motors essentially. Okay. And so we use the Trinamic. I think it's 2660. Don't quote me on that. They're somewhere on the documentation. But yeah,
I couldn't quote you because I have no idea what you just said.
Anyways, Trinamic is a company that manufactures driver chips to control stepper motors, and we just needed to use more advanced drivers essentially. So that was like one of the other major big parts to control the resonance, improve the performance. And then the third is, I guess, like future proofing. Basically, there's a lot of features that we wanted to add that can improve the experience of using the long mill and other CNC machines. For example, Y squaring would be a good example. So it's like if you have two. Like can skew, right? With the auto homing, it can like unskew itself because both motors can be controlled simultaneously. So Gerbil, as a firmware, it runs on the Atmega chips, which is like an 8-bit, like basically like a super outdated, super slow chip compared to what's available now. So the STM chips that we use, the STM32 like generation chips, they're much faster. They can hold a lot more data, and so we can add these more advanced features into the controller. One of the things that people probably like find out right away is the independent four axis control. So what that means is, as you guys might know, we have the fourth axis, the rotary axis, available with the long mill, and so
Vortex. Leanne, go ahead and grab the link to the Vortex so they can see what it is. But it's a rotary that they have.
Yeah. So right now you got to switch off the y-axis because we divert the power from the y-axis to the motor for the rotary.
Okay.
But now with the SLB, you can have an independent driver that can control both the y-axis and the fourth axis simultaneously. So you can turn and move in all three axes simultaneously, which right now isn't like, it's complicated because the software itself is also complicated, but it also opens up like a lot of potential possibilities. So for example, one project that like I want to put on the docket is doing a guitar neck in one operation. Because if you think about it, the guitar neck is like, well, I have a guitar here. It's like you have the flat side, you got to carve the flat side, and then you have this headstock, so you can do the pass this way, but then you got to flip it over and do the other side, right? And then you got to curve it back and forth. So if the rotary axis can move back and forth while the y-axis moves back and forth this way,
oh, sweet!
You can essentially make a guitar neck with one operation.
So you're technically making a four-axis machine,
like a fully controlled four-axis.
Yeah, that's cool. That's cool. So the Super Longboard can work on other equipment as well, other CNC machines as well.
So the Super Longboard was designed primarily for the long mill. It can be used with other machines. So one of our beta testers has a Onefinity machine. He's got a Onefinity machine. So we actually put the Super Longboard on a Onefinity because I think Onefinity, they sell their machines without a controller. So yeah, they were like, okay, well, I just buy without the controller, but buy another controller because there's like some features that they wanted from the control system that the Onefinity controller didn't offer at that time.
Yeah.
Yeah. So
Okay. And then the next thing you're developing is like a new trim router.
mhm.
That what's the difference between Makita's trim router and the trim router you're developing?
Let me. So I'm on a laptop right now, so I can kind of walk over to Johan's desk and show you what we've got there.
Okay.
So
Right. Yeah, we'll get to questions soon. We're already half an hour in. We got 37 questions in the queue.
yeah. Also, I'm using Johan's laptop, so I'm sorry. I
That's
forgot to
good.
bring mine. Yeah. So this is Johan's desk, and basically, see if I can find. Okay, so this is. So I guess just to like start off, in terms of what the Makita router is, it's called a universal motor. So essentially, inside there's a thing that looks like this. Well, it
Yeah.
does exactly look like this because this is from Makita.
Mhm.
But there's brushes that go here, and as it rotates, the magnetic field flips back and forth, and because of the fields induced in the stator and the armature, like the motor like starts spinning. But one of the downsides is that because there's a physical contact where the brushes are, um, there's like a resistance here and friction. Well, there's friction at the. That's like
Yeah.
one of the main downsides of a brushed universal AC motor. The second thing, which I'm not like super technically understanding, but the efficiency of a motor like this is somewhere around 40 to 60%, which is pretty low, considering that the maximum amount of power you can get out of the wall is about 1.5 kilowatts, almost 2 kilowatts before your breaker trips, right? So, like, even if, like the Makita router, once we tested it on the dyno, the output power is roughly like in the 400 to 500 watt range, and it can spike
Oh,
all the way to a kilowatt for a little bit of time. But
okay.
obviously, that's like I'm gonna fry myself sort of situation, right? So even when you're like running a job on the CNC machine, it might not act, like it's only producing about 400 watts of cutting power, because the motor is just so inefficient, right?
Okay.
That's why the main difference for us is to use a brushless DC motor, which is about 80%, 80 to 90% efficient. So even if we consume the same amount of power, you can get almost double the cutting like output power. So both the Makita and our router might use the same roughly 1,000 to 1,500 watts.
Mhm.
Um, the actual cutting power coming from our router will be about double the actual cutting power. And with the Makita and the long mill, the Makita router is kind of a bottleneck. If you use bigger bits, if you're doing heavier cuts, it
Mhm.
starts to cut down. And so we recognize that yes, we can make mechanical changes to the machine, but if we have other bottlenecks that can't keep up with the hardware, then kind of like everything has to kind of like work together, right? So
Yeah.
we identified it as like an important thing for us to develop. So yeah, I think one thing is that fundamentally the system and the how do I say, yeah, the system that this kind of router works on is very similar to a spindle. So it's sort of like hybrid between what a spindle is and a router is. We just don't really have a good word for it at this stage. So if anyone has a good name for this product that we're making, that would be great. Um, but to speak about spindles, the main problem with spindles is that the programming and the wiring is there's a lot of like hands-on stuff that you need to do to set it up. Nowadays, you
Okay.
have companies like PWN CNC, Carbide 3D have their like spindle packages, which obviously streamlines the addition of these spindles by a lot. And then obviously we've seen that becoming more ubiquitous over time. And that in that part, it's kind of a cost thing. A spindle package you're probably paying about $800. Mikita is about $100, so there's like an 8 times difference, right? So we wanted to build the spindle router thing. I like this. I like the name Sprouter. We can call it Sprouter.
Sprouter, there you go.
Yeah, whatever.
Spindle router.
Yeah.
Yeah. Okay. And so you're developing a CO2 laser as well. So let's cover that for 5 minutes. Let's get to some of these questions because they're building up fast.
Sure. Do you want me to show you the?
Yeah. By all means.
Okay.
So
cool.
for those of you who don't know, CO2 laser is a cutting laser, very popular for cutting wood and other materials like acrylic, paper, other things, but it's more powerful than your little diode lasers. It requires different technology to make it work because you can't attach the laser directly to the end of the machine head like you would with diode lasers. So you have to work with mirrors because the laser is derived out of a big tube filled with the CO2 gas and has a power going through it that generates a plasma and therefore starts to create the laser beam. You got to focus it and all that good stuff. Anyway, so there you go. There's that machine.
Yeah, so this is like an early prototype. It will not look like this in production. But I guess like a couple of things to point out here is I guess the mechanical system that they want to align the mirrors with. I don't know the specifics of it because I'm not really in part of this project, but you can see that they mounted the tube on the rail here, as well as there's a special system that they've developed that aligns the mirrors in a single piece. And so, yeah, there's like some innovations, I guess, here that are in progress. But yeah, there's a CO2 laser, and there's some test cuts that's been made so far. This is our own tech.
What is it? Oh, okay.
Competition.
Okay.
Yeah. But yeah, as Garrett was saying, as you were saying, like most of the lasers that are available, they come out of China, like one way or the other. They get labeled. We had one that was just straight from China. This one is like from China, then somewhere in Mississauga, they labeled a bunch of stuff and sent it to us here. But they are very, very similar. So yeah, one of the things about developing this is obviously to make it more user-friendly, because we have the experience of working with our users and customer base to kind of develop everything around it. And obviously there's a cost factor as well, because you can get like really high-end lasers that cost tens of thousands of dollars. There's lower-end lasers that cost a couple $1,000s. So the idea is kind of be in the middle of that. So yeah, that's kind of that. Oh, there's the Altmill there.
Okay, yeah. So talk briefly about the Altmill, and then we'll get to all these questions here. But
Sure.
So the Altmill, what are some of the key elements of that you guys focused on? First of all, it's a 48 inch by 48 inch cutting area. If Julianne, put a link in the comments, please, so people can take a look at the Altmill on our website. But so it's a 48 inch by 48 inch cutting area. And when I was talking to you guys, you focused on a lot on acceleration.
Yes, that's right. So yeah, I guess like the whole point of the Altmill was to make a machine that is as productive as possible, to balance some sort of intersection between the cost and the efficacy of the machine itself. So we didn't really think about like, oh, what's like the budget? It was like, how good can the machine be without going too crazy on the money side of things? And also like in the scope of, if I was a hobbyist or if I was a small business owner, how like what would be the best value I can get out of the machine? because the faster the machine is, the quicker people can do their projects, more money you can make from it. But obviously, like getting a bigger, faster, more industrial machine is like an investment. And the smaller the investment you can make, the more quickly you can recoup that cost. And also, if you're like, oh, I want to buy 3 alt mills to triple my business, it would be more effective than buying one really giant machine. So
Yeah, so here's the deal. For those of you watching, the alt mill, I could buy 3 alt mills for the price of that one new, and still have some money left over. So that's the scale or the scope of thinking that they're doing with that. So that's very cool. All right, Andy, you ready to rock and roll into these questions? Oh, by the way, if before we do that, in the description of this video are all the links to CNC's CNC Labs media, so your social media. Links to IDC Woodcraft. Of course, subscribe to the YouTube channel here. You can subscribe to their YouTube channel. They're always talking about what they are doing as far as their development. And the CNC Insiders, you have received the CNC Insiders is the email list that we have for IDC Woodcraft. You have received one email already because we're releasing the calipers next week. And CNC Insiders, when we release IDC Woodcraft branded items, they get a 15% discount. So if you need calipers, if you don't have them yet, you'll find them very handy with your CNC work to measure things and make sure your wood is the right thickness, you're grabbing the right tools, router bits, what have you. So there's a link down in the description to get on that email list so you can get that discount. And we also got like a golden ticket thing going on. So we're packing some of these with a golden ticket, and whoever gets a golden ticket gets a little bit of a shopping spree at IDC Woodcraft. So with that being said, Andy, you ready to pop into some questions?
Sure, let's do it.
All right. And so the first one comes from Kenny. When will we be able to have a sensor for the Y2 axis for the SLB? Activate and G sender.
I don't know exactly the answer to that. I haven't read the development logs yet. There is a version that is like in testing on the development side. So I guess like to give some context of what the Y2 sensor means is there's one sensor on the left side and the one sensor on the right side, Y1, Y2 for the homing. And so remember I was talking about the skew compensation thing? That's for that part. The Altmill will come with 4 sensors, one on X, one on X, 2 on Y, and 1 on Z, and it will have skew compensations. And they use like a very similar version of the firmware, so it is like will be out very soon. I would double check on the GitHub or like on our resources documentation for any firmware updates, because it's either already out or it will be out very soon.
Okay. On the alt mill, are you doing sensors on both y-axes?
That's right, yeah.
Okay. Thought you just said that though, didn't you? But I just wasn't sure I caught that right. Okay. Mark Eldon, the man who sent that really cool little thing to me a couple weeks ago. What could be the reason that his long mill stops with no alarm? The only way to clear an error is to disconnect and reconnect, then home the machine. Is he missing something?
Well, there can be a lot of reasons for a machine to stop. One is if it reads G code that it doesn't understand, and that might be down to like the post processor that you're using. The other reason might be from a command that might come from somewhere. So, for example, like the interference sending a signal to say, "Hey, pause the machine," for example. Yeah, there's a number of reasons. The best way to track it down is if you send a message through our contact form with a copy of your G code or a video, then we can pretty figure it out. Most of the time, it's something simple. So yeah.
Okay. Yeah, I had that happen to me once, and I figured it out, but it was so long ago I can't remember what it was. All right. Then we got Joe Lazaro, brother Joe. He's been with watching IDC for really almost since I started. He's come down and visited me several times. Took the girls out to dinner, and so anyway, Joe has actually he was involved in with PWN. He bought a long mill, right? He bought the 48 on, and so he got involved with PWN to actually get the system working for the long mill. And so Joe's one of those interesting stories who didn't really know a whole lot about this stuff, but he dove in and figured it out and just contacted people. So what will you guys continue to make improvements to the MK2? For example, newer Z carriage that allows for easier tramming and micro tramming. Good question.
Yeah, so anytime we can make improvements to the long mill, we do our best to do so. Obviously, the SLB is probably the biggest update, and we just switched over from Mark II to Mark 2.5, which is the version that uses the like what ships by default the SLB. In terms of like mechanical changes, it's sort of up in the air for two reasons. One is the scope of what the long mill is supposed to be, because the focus of the machine is to focus on beginner users, people who have never used a CNC machine before. And based on our information, based on our surveys, about 70% of that group of people who use the long mill, they've never used a long mill before. Or sorry, never used a CNC machine before. So we don't want to make the machine more complicated. But at the same, we don't want to make the machine more complicated. And there's also a cost factor, which is, okay, we are selling the machine at this price point, and every time we add something to it, it increases the cost. So do we pass this cost off to the customers? Do we build another machine that kind of tackles, like has the things that the customers who would want to pay for it would be, and so on and so forth. So something like the spring-loaded anti-backlash nuts, that was a development that we were able to do without increasing the cost, or drip. Like it was a very, very minor increase in cost, which we basically just say, okay, well, this is a better thing anyway, so we'll just throw it in for free. But something like a Z carriage that has tramming involved, that obviously costs more, but I feel like it's maybe less of an impact for a beginner. And obviously, something like the Altmill has tramming on the nod and the I don't know what to call it, this side, the router side, this way. Actually, I should say the Altmill is probably the only machine in its price point that has nod tramming as well as the regular back and forth tramming as well. So we have considered using the Z-axis from the Altmill on the long mill, and I'm not going to make any promises. And like, we just have a lot of projects in the way, but are we going to make improvements to the Mark II? Like as much as we can. Is very important for us to keep making it better. But it's like within the scope of what the machine is supposed to be and who is supposed to be for.
Right. So for those who have not purchased a machine yet, one of the things that's very interesting about what CNC Labs has done is, like Andy said, they focus on cost, but they also focus on the quality of the machine too. And when you compare the long mill to other machines, there's a significant price difference, yet the machine still performs really well. So this was the 48 unit there. And when they released the 48, I expanded. This was a Mark 1, so I upgraded this one to the Mark 2 expansion kit, and you can stand on that thing and ride around while it's carving. But all right, well, thanks, Joe, for asking that question. All right, we got Robert. Will there be a new development of a spindle that can rotate 90 degrees and route horizontally? That's actually an interesting statement. I'm almost going to guess that they probably talked about it at some point. But go ahead, Andy.
Hey, all the spindles, they rotate 360, right?
He's talking about he's talking about
Will there be? Okay, so here's the thing about 5-axis. Well, this is you're probably referring to 5-axis. Well, okay. So first of all, a lot of people they don't like rotate the spindle itself. They just mount the piece like vertically, if that makes
Mhm.
sense. I think there's a
Yep.
video on our YouTube channel where Dennis Harlock, he has we filmed him. Basically, he set it up so he can like mill the tops of like to make joinery and stuff. Um, but in terms of like 5-axis machining, it's the CAM software that's very challenging, and not very accessible at this stage. So mechanically making these things is not hard. It's the programming to like control the machine that's complicated. So um, if like in this case, probably not for a while.
Okay. Yeah, that'd be an interesting development. I'm gonna have to say that you guys are probably in the same school as I am. I don't work on new router bit designs unless there's enough demand for it. So, for example, now I've got a demand for 3/8 and half-inch tooling. So we're going to start working on that. All right. Michael Crafton, I love this question. Is a tool changer in development for the MK2?
It is kind of more tied in with the Sprouter project, to some extent. So I guess like the first one thing is that one of the reasons the SLB is important is because it has the inputs and outputs and the programmability to support tool changers. So at this stage, we don't have our own tool changer, but people can like implement their own tool changers with the Super Longboard, and also the board that will be used on the Altmill. It is something that I've started to want to have more, especially because the Altmill is so fast. The actual like it's not so much like the time to actually mill something that kind of you get concerned about. It's like, oh, I need to switch the bits around. I need to like do, you know, be there to do all this like taking the bit out, putting it back in, zeroing everything. That's the whole thing. It's like really, yeah, that's like the time consuming part at this stage. We do have the rapid auto change, I think, in the back that we're kind of testing with. I don't really know if anyone's played around with it. And then the Sprouter project is kind of interesting because with the brushless motors, they can run at a really like they have high torque at low speeds also. So in theory, we can develop a version that can rotate like very slow, like basically to unscrew a collet and rescrew a collet. That obviously spindles can't because they're limited to like a 10,000 to 24,000 RPM speed range. So
Yeah.
the answer is there a development? No, there's no like specific development happening, but it is coinciding with all these other developments that eventually will lead to the tool changer side of things.
Okay. Yeah, it's kind of cool as things are going on. Yeah, I see you guys growing. We've been talking for a good 3 years now, and seen you grow. All you had people saying to me after I released that video that you guys sent to me, you sent me all the videos of the alt mill, so I pieced that together. And people are saying when they have a 4x8 alt mill, I'm buying it. So there's other people wanting to upsize already. I'm stopping this interview for just a second to just say I hope that you are enjoying this little dialogue and getting some knowledge out of this and helping you understand the CNC world and some of the developments that are happening, and also enlighten you just on CNC machines in general, what's going on in the back end of the industry. So if you're finding this video enlightening and helpful, then please take a minute and hit that little thumbs up button down below. That lets me know that the people that I bring on board to help teach you CNC is helping you. And also a comment down below. I'd love to see what you have to say about this interview. And also, in the description of this video, there's a lot more information that you will probably want to see. So go ahead and check that out. All right, let's get on with this interview. All right, so this comes from Martin. We wanted to ask Andy a couple questions if they are going to offer any payment plans on your machines, and how is the syncing work with the rotary axis?
Well, I guess that's two questions here, but
Yeah, so
friends
you
of
got the payment.
sorry, go ahead.
No.
Okay, so for the payment plan thing, this is something that we talked about before. I have like a blog post on, not a blog post, an article on the website But basically it was like, we don't want people to buy stuff that they don't need / can't afford. I think our products are not cheap, but not where you have to finance them. So we kind of didn't make it a priority to like offer that. It is sort of kind of a moral thing, which is like, if when I guess basically it's like, we aren't so focused on selling to as many people as possible. It's more like we want everyone that does buy it to be happy, and we don't want people to feel like that they need to make a significant financial choice to do it. Obviously, there's ways that people can get financing externally from the company. So yeah, it's like something that we're on the fence about, and it's sort of like something that we kind of avoided generally because it's not really a fun part of the business, I suppose. Doing business, I suppose. So as it stands now, there's no plans to implement any payment plans, and likely into the future. In terms of the syncing for the rotary axis, I think that's kind of referring to how to like zero the rotary axis. The rotary axis has an internal inductive sensor so that it can find a 0 point. So when you set up the rotary axis, you would kind of like zero the project, sort of similar to how you'd zero your machine on a flat project, I guess. There's like a video that talks about, like, there's videos and tutorials on our YouTube channel. They go through everything. So if you check that out, it should answer that question.
Okay. And we have Rick. Will you be making a 30 by 30 alt mill, or maybe a 30 by 48 alt mill?
Probably at some point. So I guess I can tell everyone why we chose 48 as the first form factor, but the whole structure of the machine is very easy to adjust size wise. It's sort of like the long mill. You cut the rails, cut the hardware down to the size, and you can build a different size machine. So the reason we picked 48 by 48 is because most sheets come in a 48 by 8-foot size, 96-inch size. So in theory, if you have a 48 size wide machine, you can fit your 48 size sheet material and cut it out, and obviously you can slide it all the way to the back into the other side, or like the other half of it. We didn't go with the full 4x8 machine because logistics gets complicated. To ship such a big item is like difficult. It wasn't a challenge we were ready to tackle at this stage yet, but we know that people want bigger machines, and obviously people want smaller machines. So depending on the demand, we do intend to build different sizes. But yeah, we kind of like picked the one to make sure we're like all good with the process of actually making them first before offering different sizes.
Okay, yeah. I had someone else said when you come out with they didn't have the room in their garage, so they want a 24 by 48.
Come on, just get a bigger garage.
Yeah, there you go.
That's building a whole other line of machine sizes, right?
Right, yeah. All right, here's Jack in the Shop. Jack in the Shop is here every week. We are working to get him live on the show because he's such a regular here. But just for those of you that Jack in the Shop has developed he's got a toe clamp system. It drops into your spoil board, and then you just turn a screw, and it'll toe clamp your project into the whatever fence. So it's a low profile type of thing, very easy to drop in, take out. So I will get Julianne. Do you have the link to that? It's an Etsy store. Put a link to that. It's very, very quick and fast clamping method. So anyway, Jack in the Shops. If you find it, Julianne, then Jack, just put the name of your store or the link in the comments, so people can see. All right, so Jack is also you know who this guy is. He's converted your long mill into the plasma cutter.
Yeah.
All right, so he lost 4 stepper drivers now on 2 longboards. Replaced 2 on the old controller. Now both have another dead stepper. Just ordered the SLB. Does it come with a power supply driver overheating?
So in terms of like the drivers going bad, that's a pretty uncommon thing to happen. I actually was in charge of like doing the sourcing and the quality process for the drivers. So it either might be that you got really old drivers that like from a bygone era, or you got a new one and then there's a QC issue, or like it's an application issue, which is like either something set incorrectly or there's something in the shop that's causing them to fry out. So yeah, if you want us to look into that, just send us a contact and give us a bit more information and we can identify what the problem is. But yeah, I mean, drivers frying is very uncommon. Maybe like a couple every month, maybe not even that. Well, let me just think, because I read through all the technical support tickets, so I can like make sure that there isn't like a recurring quality issue.
Okay.
Yeah, but I haven't seen anyone have bad drivers for a really long time. So I think that means I ironed out that quality control process. But yeah, just send us a message and then like we can identify what the problem is. But in terms of the SLB coming with the power supply, they use the same power supply as a long mill, the longboard, the original one. They're identical. So if you have the old one, just use your old one, and you'll be fine. We also do sell them on the store. So if you need another one, you can buy them on our website.
Okay. So the clamp that Jack has developed, this is an early rendition of it, just so you know. That's what it looks like. It's got the 2 pins right there. You drill holes in your spoil board 2 inches apart. Those pins drop right in. Then you start to screw the clamp in, and you can see it comes down at a excuse me, at an angle. Very cool little clamp system. So that's Jack's clamp. Okay, let's get on to the next one because still over 40 questions. Will the Altmill signal the phasing out of the MK2? Well, so I guess the question is, will you be phasing out? Oh, the MK 2.5.
So I guess there's like a couple layers of situations. So the Altmill targets a very different audience. So based on our survey data, about 80% of the customers that we have, they're not long mill users. So most of the people that get alt mills, they're not going for, they never started with a long mill. They just went straight to alt mill. I'm like, I need the big fast thing instead of the beginner friendly thing, if that makes sense. So because they're two very different products because of the market, it doesn't like one doesn't imply this phasing out of the other.
Mm-hmm.
However, the thing that I think is something that's more on top of mind in my case is that a lot of the technology that we're developing for the alt mill will trickle down to the long mill, and obviously a lot of stuff that we did for the long mill also goes like impacts how the alt mill was developed. So I think that also means that there's a lot of potential for the long mill line to change a lot in the next coming years, because a lot of things that we've done to make the alt mill good, we can use those same techniques to make the alt mill good. We can make the long mill better as well. So as long as there's a viable market in this segment of like beginner friendly machines, I think the long mill will continue to be a viable product. I think at this stage, because of our expansion into a different segment, it means that the long mill has more potential to grow quickly to be better in the long run.
Right. So he mentioned the MK 2.5. So this is gonna, what does that mean, right? So explain to them what the 2.5 is.
So there's two main differences for the 2.5. It's that it comes with the SLB by default, and it has the spring load and anti-backlash nuts. There's also some minor changes, such as injection molded feet and the improved lock nuts. But if you bought a long mill probably in the past 6 months, you already have the lock nuts, and the feet are more of like an improvement in the manufacturing process and not so much like a performance improvement. So anyone who has a long mill already, basically, if they want what the 2.5 offers, they just need to get the spring-loaded nuts and the SLB, which we've priced set to be like not that much, like how do I say, to a price that point that we think is pretty reasonable. I think it's like $220 Canadian. It's like 170, 180 US for the board, and I think about $25 for a set of nuts. Don't quote me on that. I can't remember. But yeah, it's like an upgrade path that pretty much gets you to a 2.5. But I think I always tell people, like, if you're already happy with the machine, you don't need to change anything. Like a lot of these they're improvements. They're not like fundamental changes. So yeah.
Yeah, Julian, throw the SLB link into the comments. So one of the major things about the SLB that I've seen is the machine, has a much faster rapid. Does it have a faster acceleration rate as well?
Yeah, so that's faster in both those cases. The motors are also quieter, and because of the processing speed is faster, it can home and probe faster as well. Because there's like, it's like there's that delay where it like detects the signal. That's like much faster. So I don't remember exactly what the time was, but I remember we had one of the developers like doing the testing in it, and they told me like this is a lot faster. So
Okay.
yeah.
So for those of you who are, we're talking about acceleration. What's the deal with that? So acceleration is the amount of time it takes for the motor to go from 0 to whatever speed that it's set at, and then there's deceleration because so as your z-axis moving up, it has to accelerate up to the travel speed, the rapid speed, whatever it may be, and then it has to slow down. And so all that has to be taken into account when they're designing stuff. So that's one of the major impacts when you're doing something like a 3D carve. There's lots of accelerating and decelerating because the z-axis is doing a lot of this, your x-axis is doing a lot of that, and your y-axis is doing a lot of that. So all this has to work together. So acceleration, deceleration is the main reason why 3D models take so much longer. And that's one of the things that like the Altmill, that really blew me away is how fast that thing runs. I'm going to show you a clip real quick of it running that big block of elm that you guys were doing, to show you what I mean, how fast they are accelerating and decelerating. So can you see the video? It's sitting idle at the moment. Can you see it? So let's wait for it to move up a little bit. Look how fast that's moving across and how fast that's moving up and down. So this is one of the things you guys were working on. Once we get back into, there you go. Your focus almost couldn't keep up with that.
Yeah. So I think like in practice, I think roughly you can do a project about 8 times faster. I think, I don't remember exactly what our settings were, but I think you can do like, I think this was set up for 7,000 millimeters per minute. I'm trying to remember what that is in inches.
7,000 is about 250 inches per minute.
Yeah.
So
and that's like a full depth pass.
What's that?
That's like there's no roughing for this job.
Yeah. So how far into how much time into that at that level right now?
I think the whole project took about 4.5 hours.
Are you kidding me?
Yeah.
That's the difference with the acceleration stuff.
Yes.
That's like insane for a piece that big. That was really large piece of elm.
Mm-hmm.
So anyway, yeah, there you go. I'm still blown away by that.
Yeah. So I think one thing we were talking about earlier was the acceleration, because so I went incognito and I like contacted a bunch of CNC manufacturers to ask about the acceleration stuff. And one thing that was very interesting was nobody gave me a straight answer. But if you look at like the content that they put out for like the machine video, the accelerations are really slow. Like if you look at the Phantom stuff, it's like a big chunky machine, and it can run fast, but it accelerates slow because, you know, the faster, the bigger and heavier the machine is, the more power you need to accelerate it. The Altmill comparatively is pretty light. I think altogether is in like 200 to 300 pounds, I think. Right. So yeah, you can like accelerate it faster. But it is more prone to what's the word? Resonance, vibration, if that makes sense. So there's a bit of a trade-off. The machine can run faster, and if you can manage the vibrations better, then they're comparable. But it's also like, you know, I was thinking like, okay, well, you can buy some like a industrial level machine for like $7,000 to $12,000, right, of the same kind of size and scope. Or you can buy an alt mill for like $4,000-ish, and then you can sandbag it and do like something pretty similar. Because one of the advantages the bigger, more industrial machines have is just sheer weight. So if you can weight it in the machine, it kind of serves the same effect.
Mass does that. So there was a question there from Pat White. He must have shown up late. Pat, that is the new machine that CNC Labs has put out called the Altmill. So you've got it list priced at like $3,000, right?
Let me look it up again.
Yeah, $3,000, and then maybe $600 for the spindle edition.
Yeah, so $2,950 for just the machine, and the spindle is an extra $515.
Are you back ordered on that right now, or what's the status? When do they ship?
So we're still taking orders. The first batch we're starting to ship at the end of this month. We're starting have the assembly station over there set up to do this first batch of assembly, and then probably if you place an order now, it'll take. Let's check the list. Yeah, I think probably in the fall, like September, October.
Okay. All right. So Julianne's putting a link in the comments for you all, so you can take a look at that. All right, let's get on to the next one then. So Jim asked when I'm getting the SLB for my MK2. He said, don't miss out. Yeah, even Longmill didn't. These guys here didn't even realize I didn't order it. They're going, you didn't get it yet? So I have to go ahead and get that. So Julianne put that on my list, the Super Longboard. Heck, I got the Vortex from them 3 months ago, and it's still sitting there in a box. See, part of this for me is when I'm doing this, I'm always thinking video content. I want to teach people how to do this stuff. So that's coming up on my list of videos, the unboxing and how to set it up. And I also got a vacuum system for the benchtop machines. I got to do that as well. So, all right. We got built by Biddle. And this is to Julian. Has anyone asked if the controller can handle? Okay, this is for you. Can the controller handle ATC integration, such as PWN's ATC? So, first of all, for those who are wondering, PWN is a company that has come out with a spindle, basically a plug and play kit. So I had upgraded my long mill to a spindle, and so basically you buy the spindle plug and play kit. You have to install the spindle into the machine, but basically all you have to do is plug it into the controller. Not a lot of technical stuff that you need. They've already taken care of that. So it's basically a plug and play. And they've come out with spindles kits for the long mill, Shapeoko, Onefinity, CNC for newbies, MillRight, and there's several others. Julian, throw PWN's link in there, so you can see if you're using a trim router, the spindles are much better for the CNC. They're designed for the long term. I had a trim router on my long mill, and it gave up the ghost after some time. So that's what you're developing in your trim router. That should not happen nearly as much because it's a non-contact type of thing.
Hopefully, it won't happen at all. But we
Okay.
are using like spindle grade bearings. Like it's basically like spindle construction.
Okay.
So yeah, in theory, well, I'd like to think that because we're sourcing and testing our own bearings, they'll uh, they'll last longer.
Oh, it'll cut better too. So that's
I,
better.
you should see
So
the engineering documentation. We have like probably like 140 pages of like, yeah, it's crazy.
right. Actually, this question was already asked about ATC integration, right? So I guess they're talking about the SLB. So Andy did answer that question before, so we can pass that one up. And Rick is okay. He asked if there are any plans to make a 30 by 48 alt mill. We already addressed that one. Is the SLB an easy upgrade? It's a question from Mark for the new long mill CNC for a
I
new
would
person.
I would say yes. One, because Chris made a lot of documentation on how to do that. Second, it's plug and play. And three, you don't need to make any modifications. So I think probably in like 15, 20 minutes, you can pop on a SLB.
Okay.
Yeah.
All right. Even for someone who's not that they're really relatively new to the whole
For sure.
CNC.
As long as people know how to, like, as long as they follow the instructions, should be fine.
Right. Okay. So basically, with the current longboard, the longboard is the control box for it's this guy right here.
Yep.
And that's the controller for the CNC router. So all CNC routers have their own set of brains, and that's the one on the long mill. And so the Super Longboard, well, this one here has a max runtime. You guys a rapid rate that you guys set at for Imperials about 157 inches per minute, which is 4,000 millimeters per minute. All right, and that's because of the limits of the electronics and safety levels built into the electronics. The Super Longboard can handle more, so you get a much faster rapid rate on that as well, and
Yep.
higher accelerations. So, okay. Mike asked any spindle recommendations other than PWN. This budget won't let him get that high. So the PWN spindle upgrade kit is like $800. So that's why he's saying that. Do you know of any alternatives that are relatively easy for someone to do?
So, shameless plug, I guess. Obviously, we're making the spindle kit for the Altmill, and a lot of people have been asking, "Hey, can I buy this for a not Altmill machine?" And basically, we can sell people stuff, but we can't promise we can help them put it on.
Yeah.
But the process and instructions on adding it to the Altmill is almost identical to the long mill with an SLB. So, in theory, like there shouldn't be too much work to do it. But yeah, that's pretty much that.
Okay.
Uh,
All right.
I did write an article on our resources that covers like how to add a spindle and kind of the warnings for doing that. So you can check that out if you want.
Okay. One of the things I like about what you guys do, you spend a lot of time on instructions to make sure that the instructions are as clear as you possibly can make it. You spend a lot of time on visual type of instructions. So that when you put together the machine, a lot of it is picture based. So it's very, very, very well done. And do you have any agents in South Africa?
Oh, yeah, I got like secret agents, spies down in South
Yeah,
Africa. People
yeah,
steal
yeah,
your stuff? No,
yeah.
unfortunately
Yeah.
not.
So are you going to open any offices in other countries, or you've set up in the United States now?
Yeah,
Are you,
so we don't have any distribution agents. So anybody like nobody sells CNC stuff except us, and we have reasons for that. mainly because we want to make sure that the experience that people have in terms of like buying the machine and getting it set up, like that's all there. But we may like we have a legal entity in the US now to handle like the taxes and the shipping and all that sort of stuff. But we do have the opportunity to set up a physical distribution to help facilitate like machines going to our US customers. Because right now, most of our customers are in the US. So that is like something that's on the docket. There are like considerations for Europe as well. We don't have a lot of customers in Europe, but we do have like a fair number. So yeah, I don't know. It's like kind of complicated.
Yeah. Anytime you want to set up, I can tell you from just as a business myself, IDC Woodcraft is a CNC router bit company, as most of you know. And so it takes a lot to set up in other countries. So there's a lot, you got to understand their laws, their taxes, the licensing that you have to develop or whatever. It's just a technical challenge that it takes a lot of work. Okay, so we got Daniel. He has his first question. In making signs, they're carved with 1/2-inch V-bit, and then this is more of a okay, 1/2-inch V-bit and then profile cut. Can he use his probe with his 1/2-inch V-bit by rotating the 1/2-inch profile for X and then rotating for Y? Okay, I see what you're saying. He's got to. So what you want to do is you want to rotate that V-bit so the blade is sitting one way, so you can probe it one way, and then bring it over to the other side of maybe your touch probe and rotate that bit 90 degrees, and then come in and manually touch it. So can you do it with the setup? Can you manually use a probe, like slowly bring the machine in while it's ready to probe?
So the answer to this is you can do this, but there's always going to be a margin of error. One depends on where the contact point of the bit is going to be and how accurate, like, do they make it as a 1/2-inch. But there's something called the auto zero touch plate that Chris made some time back. And you can zero V-bits and tapered bits and ball nose bits, and you don't need to do the touch off on the edge. Basically, the way it works is there's a really shallow dish, I guess, or like edge, where it assumes that the point of the V is infinitely small, and because it's at a really shallow angle, the tip of the bit contacts the side of the slope, and basically by touching off on each corner of that slope, it's able to calculate the center of where that bit is supposed to be. So yeah, there's an auto zero touch plate. As far as I'm aware, this is the first touch plate that does this, and as far as I know, this is the only touch plate that does this. And if you use G-Sender, it has all the calculations done in the back end. So check that out because that's really cool stuff.
Yeah, Julian, I guess you're finding a link to show people that. Yeah, go ahead and find that and put that in there for the auto zero touch plate. Now, is that only set up for G-Sender, or are there any other control software that can run that?
So we have the macros and the code that you can import into different programs, like Mach 3, but we don't have official support for it. And G-Sender is like, we have everything built into G-Sender, so I think it's a more reliable tested system. Secondarily, I should add with the SLB, because the probing sensitivity is a lot higher with the SLB, if you use the auto zero with the SLB, it'll be even more accurate. Obviously, like, we've tested it to be in the sub-millimeter accuracy point, which is
really?
Wow. Yeah, which is more than good enough for this application. But it's even better, which, yay. Yeah, so.
Right. Okay, so here's basically how this works. Julianne, expand my screen, please. You got the V-bit, right? And so the problem with the V-bit is of course it's a V, and so you can't necessarily use a regular touch plate. So inside that touch plate, like Andy was saying, I don't know if my camera can pick it up, but we got a flat surface there, and then it tapers up Very shallow taper all the way around. You can see it there. And so when you're using that, this V-bit will raise up just a little bit, and it'll come and touch all four sides of that, and then it does the calculations that way, and then it moves out to the 0 point and positions itself. So it's actually a pretty interesting thing to watch run when you're just used to the 3-point touch plate. All right, you can bring Andy back in. Okay. All right, Darren, Andy, is the price of the Altmill including delivery, or is it a supplemental charge?
So the price of the shipping isn't included in the base price. You can get a calculation of what the shipping will cost on our website when you go through the checkout page. On average, it'll cost between $120 and $250. Most of the shipping that I've seen go to the States is like in the 150-ish range, so not too expensive. It was a really important part of our development, because with really, really big machines, the shipping can be very expensive. And once you go into freighting, that's a whole nother thing. You need a lift gate, you need pallet jacks, and all this sort of stuff. The Altmill is split up into 3 or 4 separate boxes that weigh about 60 to 70 pounds. So they're more manageable, and they'll ship straight to your door. So yeah, so there it isn't part of the cost, but it isn't too crazy also. So yeah, if you're interested, check out the website.
All right. Any updates on a possible 24 by 48 Altmill coming? So you talked about that, and you said it's not out of the question. So he did already cover that one. Randy, woodworking, how do you rank the Altmill in comparison to the Longmill, as in power, speed, etc.?
So yeah, if you go to our website, and there's an article called "Everything You Should Know About the Altmill," there's a pretty long comparison between Altmill and Longmill. As I was saying before, basically in terms of power and speed, there's about an 8 times difference. We were able to do a project about 8 times faster.
Joanna, will you find that page, please?
In terms of, but it is double the cost, so trade-off, I guess. Yeah.
All right. So Julianne will put a link to that page in the comments, and that will also be in the description later on. Has a 48 by 30. You have a 30, and we'll be building a table. He has seen your recommendation for 78 inch by 48 inch. Is that the best way to go as far as table size?
David, you got to understand, whatever we recommend is always the best way to go. Why would we recommend it? No, just kidding.
Right. Yeah.
Well, I guess like the thought process of like making it bigger is that a lot of times people want the extra space to put some tools or put a laptop and things like that on the left side of the machine. So yeah, a lot of people go all the way to like building their table to a full 8 feet. I think the 48 by 40, sorry, the 78 by 48 is probably like the recommended like minimum. So you can put it on any flat surface as long as it's big enough. You can make it bigger if you need more you want area to like put all the other stuff. So yeah. But anyways, if we recommended it, you should take our recommendations.
Right. My table for my 30 by 48 is 48 inches deep by 6 feet wide. And so that actually is kind of tight because it doesn't really give me any extra room other than to put the longboard controller on there and the PWN spindle control. So I would say go a little bit wider than, so what they've got on there, they got another roughly 10 inches. Go for it. All right. Altmill is faster than the Longmill. Are special bits required for faster speeds? So I guess I can answer that question. Your feeds and speeds, the higher you go, you have to alter your feeds and speeds. So the faster you're feeding, you need to alter your spindle speed to compensate, because you want to, in the science level, you want to maintain your chip load. And you also got to take into account, just what the tool is designed to handle. There are limits that it can go. So it doesn't necessarily require special bits, but in running faster, that's one of the reasons I got the Phantom, to test router bits at higher feed rates. I want to know the breakpoints of them at different feeds and speeds. So, and then we can dial it down for whatever we need to do. But the short answer is no, you don't necessarily need to get special bits. You just need to understand the feeds and speeds that you need to be running at. The stuff that clip that I was showing, you were running out of 24,000 RPM, right? So you're at a really high spindle speed rate because you're running so fast through the material. Some of the other clips, you were doing the same thing. I should probably show that.
Yeah. So there's like two things to the Altmill, which is one, the machine is so fast that the spindle is kind of a bottleneck. What I found, I couldn't run the job faster because I was breaking the bits. In theory, if we can run the spindle faster, we can cut faster than what's being shown here. So yeah. Also, these are all we only in our store we only carry up to 1/4 inch size bits, but the Altmill can support larger end mills, like our larger diameter end mills, which allows for more material removal. And because it's more rigid, you can also cut deeper as well. We have a video coming out where we made a guitar out of aluminum. I can show that to everyone later. But I think we used 3/8 inch bits for that primarily. But yeah, we were making buckets. I think we got a 50-pound chunk of aluminum and we brought it down to 20 or something like that. Yeah. Mike was joking oh, we bought a $500 piece of aluminum and we're only keeping $100 of it. We're just making $400 with our aluminum chips. But yeah, I'm pretty.
I gotta go back to the video because I gotta show the aluminum cutting.
Yeah,
because
this is just a taste, but that's this is the the big the thing crazy thing.
Right.
Yeah, there's the sample blocks that we use to make sure the profiles were good.
Okay.
But yeah, the speed at which we're running these were very, very fast.
Yeah, that's really fast. But even when I dealt with CNC machining, we never ran router bits that are cutting end mills that fast. That was pretty wild.
Mm-hmm.
All right, let's get on to the next one. Where are you with spindles for the long mill?
Where am I? Well, I guess there's two things happening. One is the sprouter, I guess, sprouter project, which is it's like a hybrid of the spindle and the router, and then we have the Altmill spindle that we're working on too. So it'll kind of accumulate to those two new options probably.
Okay.
Yep.
So is that the spindles? I mean, we did talk about that before, so that's something that's kind of on the horizon, but no solid projection yet.
We probably won't have a spindle option available until we get our first batch tested. So we'll have our first 50 close to the end of May, third week of May, I think. And then if they pass through QC and setup's all good, then we'll make them available to the general public to buy. Mm-hmm. Yeah, so that's sort of where we it.
All right, from Mike, SLB, e-stop, 2 e-stop buttons. Can someone do a slowed down, more deliberate directions video on how to program the e-stop buttons? He tried, but it's not working for him. So he's asking you for some guidance on that. If you guys can create some content to explain how to do that.
Well, I can pass it to the resource development team and ask them to put it on the docket.
Okay.
Yeah, but those programmable e-stop buttons are pretty cool. They're like super handy. If you guys don't know, the SLB also comes with a new e-stop design, which has a e-stop, but also has 3 macro buttons. So if you press those buttons, you can program to do whatever you want with the machine, not like in general. But like for example, one of our beta testers, Ian, he programmed it because he needs to bring the machine all the way to the front corner to do the tool changes. So you press the button and it like brings it all the way to the front. You can set it up to do a homing cycle. Uh, they're just like macro buttons, but they're physical, so you can press and make them do stuff.
Okay. That's cool. So it's
Yeah.
3 buttons you can program on it then.
There's 3 buttons, but you can actually add more buttons if you like wire in more stuff. Like there's an input output like part of the SLB.
Okay.
So
All right.
yeah.
From Jerome, what's the reason why when he zeroed G-sender while an error popped up instead of retracting the Z plunged into his board, resulting in damage in the router? Is that a software issue?
It's hard to say what the problem is without knowing what the error is and what the situation was. It doesn't sound like something that should happen, but if you want to get in touch with with the technical support group, they should be able to sort out what the problem is.
Yeah, Jerome, I would say I would troubleshoot just to make sure all your connections are tight. All your wire connections are snug and tight.
And are you like, I guess like one of the common things that might happen is if you press go to 0 instead of zeroing the axis, then the machine will like go to the 0 point, which might be where the board is.
Yeah, I've done that.
Yeah. G-Sender development team is updating G-Sender UI to make that less probable. So yeah.
That's a good question.
Mm-hmm.
All right. So from Steve Bradley, can he trade his brand new LED 1515 for the Altmill?
Why would you want a less great machine? No, just kidding. Yeah, we don't really trade machines, unfortunately.
Right. Well, I think he bought the machine. Now you find out something else has come along that you'd rather have had, or maybe it's better. And you're like, darn it, I just missed the bus. So I think that's what that question was geared for. So from let's see. Has there been a plan or discussion around the idea of developing a standardized vertical milling setup for the Altmill?
Not really. So obviously, people do set up these sort of things for their machines, but it's pretty uncommon, at least that I've seen. So there doesn't seem to be like a need from the community as much. So it's not a priority. If you do feel like it should be, we have like a feature request form on our website. You can search it up or go to the FAQ, and there's a link to that, and then you can tell us what you have in mind. That being said, the Altmill, like I guess the structure of it does make it easier to set up the vertical milling stuff, because you can kind of like there's several cross beams that go across the machine, and you can remove the cross beams if you want to like have a pocket, or you can like just cut out the front part of where the spoil board goes, or you can like make slats to put on top of them. There's like a lot of ways to like kind of make them. So there isn't any specific plans for us to like offer that as a CNC Labs kit or anything, but anyone with enough determination. Also, there's like a guide on how to do it on the long mills, so I feel like they should be able to do that.
We are 10 minutes before the hour, so take a minute, brothers and sisters, CNC creators who are watching this, to give us a thumbs up for taking the time out, for Andy taking the time out. Subscribe to the IDC Woodcraft YouTube channel. Go find the down in the description, there's links for everything we've been talking about. Go to the Long Mill's YouTube channel. You'll get a lot of guidance there on what they've been doing. And they have a Facebook group, Long Mill Users Group. Just type in Long Mill on Facebook and you'll find it. Subscribe there. They've got you have a weekly competition that you do, right?
Yep. Yeah. If you have one of our CNC machines, just post a picture of your project, and we pick like a small handful of people to get a couple bits or a little goodie. Yeah, no strings attached.
Right. All right, cool. Yeah. I think I need to start doing that. All right. This comes from Scott. If I have an MK2, what benefits could he gain from getting the SLB?
Chris has a really great video on everything on why the SLB is so great, but more speed, better reliability, faster homing, faster probing. It's got lights. There's a lot of cool stuff for it. So I'll check our website and our resources there.
Okay. And Australian Bug Detection Group. Alan from Melbourne, Australia. Hey, Alan. With the Altmill. Given it has its own stand, what space provisions are available for an enclosure? So on that note, the Altmill comes with its own stand, right? For the Long Mill or many of the other benchtop units, we need to build our own table. This unit comes with its own stand.
Mm-hmm. Yeah, and one of the reasons, there's a couple of reasons we included it. One is because you need a strong table, and we want to make sure that the table that people are going to use is always going to be strong. And how do you do that? We just give them the table. Secondarily, it's a whole hassle and cost to build a table, and I think we had kind of a $120, $150 kind of like table cost that we added to the Altmill. So we kind of like make the decision for the customer to include that. That being said, like those table legs don't need to be used. They can be like removed, and you can build the machine, like stuff around the machine. So yeah, if you want to build an enclosure, by all means. Or you can kind of do a hybrid where it's like you have the machine, but you put an enclosure on top of it. That would also work too. And we have like mounting points on the table legs itself to put like shelving and whatnot. So yeah, we'll have more.
So yeah, I can say just by looking at the picture, Julianne, throw the link to the website in again directly to the Altmill, so you can go look at the picture and you'll see they've maximized the space. It's not like there's flanges on the edge where you can build fixturing up on an enclosure. So you'll have to be what's the word? You have to be inventive. But if you build an enclosure, you can let Altmill know or go to the forum. They have a forum as well, and that's the information gets posted, right? So that your design, once you come up with it, can help other people. All right, so we have Clay from Cincinnati, not too far away from me. Andy will be buying his first CNC soon. Why should he buy the Altmill versus the Shapeoko Pro?
Good question. Well,
I love competitive questions.
Huh?
I love competitive questions.
Right. Well, the main thing is that if you buy an Altmill, I can pay for a better haircut. Well, like to be frank, the Altmill was like designed to be a direct competitor to the Onefinity Elite and the Shapeoko 5 Pro. If you go to our website, like if you look up our article on everything you need to know about the Altmill, we go through like a comparison on terms of rigidity and things like that. So in terms of performance, I think the Altmill is really is a better option. There are some downsides though. Obviously the Altmill is a brand new product. It's not in the hands of our users yet. And so that's like the other trade-off. So I'd say if you're willing to wait and if you want to support our company and what we do and what we believe in, by all means. But I think the Shapeoko 5 Pro is a really good machine as well. And it's supported by a really good company as well. So I think you can't go wrong with either or.
All right. And incline decisions. Any dust boot yet for a spindle mount for the Longmill MK2? So if you got the spindle for if you got a PWN spindle, they've got their dust shoes. Do you have one developed for the 65 or the 80?
Yeah, so we have so the Altmill spindle is a 80 millimeter, and we have an 80 millimeter dust shoe as well. So that's also going to be like available open source, so people can make their own if they want. Obviously, there's lots of dust shoe options. Like I bought one on Amazon to try out. I guess there's like stuff like this. So basically, most dust shoes, they just mount to the spindle, so you just have to match the diameter and make sure it doesn't crash into anything. So yeah.
All right. He bought a shop bot, buddy. Have I made a mistake? Shop bots. So I don't know what the shop bot. I think that's the little 2 foot by 3 foot machine from ShopBot. But asking if he made a mistake, I don't think he made a mistake. ShopBot's a good company. You know, they make some pretty robust machines too. They're more expensive. You know, but can't really say that. Can't really answer a question like that. Hey Andy, I know you keep mentioning future proofing. Is there any notable feature that you are working on implementing as part of future proofing?
Maybe this is like a good time for me to share the tablet thing I was talking about earlier. Just because I want to know, like, because we have a kind of a big audience now, and I can judge like what people think about it. Is that all right, Garrett?
Yeah, go for it.
So okay, so like as an introduction, part of the SLB project was to make the connection more reliable, like basically not have the machine stop for any reason. The computer is like kind of the other side of the process, because right now a lot, like for you to use a machine made by our company, you need to plug a computer to it, and if the computer is unreliable, that causes its own problems. So my solution was, what if we just made our own computers? So I got this thing, which is basically a touchscreen tablet that can like run GSender, and it's a 16-inch screen. It's like has a mounting for VESA. We have a mount designed for the long mill and the alt mill, so that you can like have it pointed towards you while you do stuff on your machine. So I guess, well, part of the future proofing is, I call it the wizard behind the curtain thing, which is basically like we can make the board more advanced and we can make the control system more advanced. Like basically the computer can tell what the machine should do, or the board itself has all the programming for the machine to do actions based on what the computer commands it to do. So if there's kind of a limitation to how advanced the board can be, based on like the chipset that we use, and the other hardware aspects of it. But on the computer side, GSender development team continues to add features to GSender, which translates into features that are part of the machine. So yeah, the computer side is kind of an important part of this as well. Some companies choose to make the controllers more advanced, but the computers can't be upgraded because they're like a contained unit, or the boards are really primitive and the computer side is like can be upgraded. And I think at this stage we're kind of in the let's make them separate so that the computer can develop and the SLB can develop both separately and at different paces, which never makes sense at the time. So at least for the tablet thing, basically what this is a POS system. It's like the screen that you like if you go to a restaurant or a bar. When people like tap in the orders and stuff. This is just like this is a screen that they use for that. But this is pretty inexpensive. I think that at bulk, we can buy these for about $180 US. So I think if we mark it up and we do the programming, make a kit around it, if we sold it for like 400-ish dollars, maybe that would be like a product that people might want. Because the idea is we'll have all the software pre-installed. We'll have everything like set up. We'll have the networking so that if you, I have this one network so that I can design files and G code on my main computer, and then it's networked directly, so I can drop files directly onto the computer remotely. So I can just walk over and do it. Yeah. So it's not designed to really run design software. It's not a very powerful computer, but it is capable enough to run the software for running the machine. And there's obviously like other inputs and outputs. So if you want to add a camera so you can monitor remotely and things like that, it's also touchscreen, so you don't need like the mouse and keyboard. You don't need to worry about the dust getting on it and stuff like that. So yeah, what do you guys think?
You're already getting a bunch of yeses here. So they would love that. They're interested in it. Plug and play. Yeah, a lot of yes, that would be awesome comments. No, I think that'd be great.
Mm-hmm. So yeah, I think one of the common control systems out right now for this space is the Maslow.
Controller.
I think this kind of like offers an alternative to the Maslow. One, because like the controller itself, we have, and then it's connected to a touchscreen interface that's like designed for controlling the machine. But I think this will end up being like a third of the price. Also, like I should add, we are developing the SLB EXT, which is basically the controller that gets used on the Altmill, but it allows for external drivers. So if you want to use closed loop steppers or like drivers that aren't like the TMC, the Trinamic ones, we're able to do that too. So.
Right. All right, we're at the top of the hour, so we'll handle a couple more questions we have to check out. There's still 16 in the queue, so I do apologize for those we can't get to, but obviously we need to have you back on to handle some more of these questions. But I would like to, before we handle the last couple of questions, if you decide to go this route and buy the Altmill or something like that, the links we've been putting in is an affiliate link that does give me a little bit of credit. So if you get it through that link, it gives me enough to buy a burger and a beer. So I'd appreciate it if you would use those links. Longmill's been kind enough to give me those links. So, all right. And again, like the video if you feel like we've done this. You got a lot of information out of Andy. I'll be bringing more people on board every Wednesday, 8 o'clock Eastern Standard Time on the IDC Woodcraft channel. It's usually me and Kate, but Kate hasn't been here. Kate from Women Who CNC, Bears Custom. Just missed a good deal on a Longmill MK1 on the Facebook Marketplace. Wasn't sure if he should spend to get an MK2 or save some cash to get a used MK1. What are the advantages of the MK2 over the MK1?
So first and foremost, the Mark 1 and the Mark 2 do the same things. They work the same way. So whether you go with the Mark 1 or Mark 2, they're both really good options. I think it really kind of comes down to how much the Mark 1 is. Because if you get a really good deal, yeah, for sure, get a Mark 1. If it's not that much different than a Mark 2, I think a Mark 2 is a good option. One, because it is more rigid. We have like custom new extrusion design. It is a more simple machine mechanically, so it's easier to assemble, and it has upgraded hardware. So those are all improvements overall. And we moved away from a lot of 3D printed components to improve like the longevity of the components as well. Obviously, we sell the printed components and all the parts still available for the Mark 1 on our store, and they're all open source. So if you ever need to make your own parts, you can just download the designs off online to do that. So yeah, I mean, they're both really good options. I think generally I've seen on the market, the price for the used machines are actually pretty high. And there's like a lot of mislabeling. People think a Mark 1 is a Mark 2 and things like that. So I would just like be careful on those aspects of it. But yeah.
All right. Okay. Woodcutter. Can you elaborate on the tramming procedure for the Altmill?
So I won't go into too much detail because it is kind of complicated,
Sure.
and we'll have more documentation on doing that. And I should also like say first and foremost, the precision of the assembly and all the mounting components for the machine are very, very high, and you need special equipment to get better than what we're going to give you right off the out of the box. So I don't really recommend people going through a tramming procedure unless they really like. You can do it. Like I think it's like a interesting process, but it realistically it's not very like useful because of the level of precision you need to be able to measure at. So
Okay.
basically, the idea is you get a really flat surface. Usually, you can use like glass or like a surfacing plate, and then you have something called a like a tramming, like a gauge, like a what's the word called? It's like a that thing that's like circle, and then it has like the little
It's got the
yeah
indicator.
yes the end yeah that thing. You get two, and then you rotate it, and as you rotate, you can see how tilted the router is or the spindle is in both directions. And then on the Z-axis plate, there's eccentric nuts. So by twisting, you loosen the bolts that hold the gantry on just a little bit, and then the eccentric nut tweaks it very so slightly, like back and forth, like sub-millimeter amounts. And then once you get the right position and your gauges are zeroing out, you bolt back everything, and then it locks it into place. The nod adjustment, which is this way, back and forth, there's also bolts and then eccentric nuts that basically tweak it backwards and forwards. So same sort of process, just in the X direct, like in the on the X rail. Uh, when it comes shipped, it'll come with shoulder bolts, so they're like straight, like locked in place. So you remove those and you replace it with another bolt to do this whole tramming process. It'll come with everything, but I feel like most people won't end up touching it.
And then there's a question: when is the sprouter going to be released? What's the time frame?
So this was supposed to be like a pretty short project, but it's gone like very, very long. I think we started last September, and I think realist. So I guess like behind the scenes, what's going on so far is that we went through a couple prototypes, so we got different motors and we started testing them. But the main issue right now is the speed control. Basically, we need the motor to react really quickly. Like as it enters the material or as it exits the material, we need the motor to respond really quickly. If you guys are familiar with like chip load, the speed at which the spindle rotates or the end mill rotates dictates how much material is getting removed. And if it slows down, it's a bad time because your chip load becomes really high. And then as you continue to increase the chip load, then the load on the bit gets higher, and then it's a vicious cycle of getting slower.
Right.
So if the Makita has like a speed compensation that makes sure it runs at the same speed, it's not super fast, but it's pretty good, and which is why one of the reasons we like the industry itself recommends Makita routers, because it's good speed control. And on the spindle side, I think of like it's kind of like the brute force method, which is if you have enough inertia, the spindle can basically and enough inertia and enough torque, it can like outpower the cutting forces. So there's no dip in speed. But because the sprouter that we're working on is more close to inertia of a router, we don't have that inertial effect. But we can react to changes in speed faster than what a Makita can do in theory. But it takes a lot of tuning and a lot of like understanding of the motor, the way that the motor works, and that's like what we're stuck on right now, because we're very, very close to what the Makita, like we're pretty much at the Makita level, but we want to get past that. So Johan is actually in Hong Kong now. He's planning to go to China to work directly with the manufacturers of the motors, because we have all the knowledge of the testing and like measuring the speeds and everything, but and China has the manufacturing knowledge. So we're trying to like combine those things to get
Right.
the best option. But yes, we had like we made a lot of mistakes on the way. The first batch, like we got the closed loop speed control on the first motor, but the motor wasn't powerful enough. The second version was open loop, so then the speed control was wrong, but it was powerful enough, and it was a whole thing. But every time we do this, it takes a couple weeks to motor.
Yeah, it's the technical challenge you deal with when you're developing new products. And to think, I just deal with router bits. He's dealing with machines, so very complex, much more. So I didn't see this. Actually, Steve Kincaid donated $10 super sticker to us for tonight. So thank you, Steve, if he's still on. Some people are starting to drop off now. But I'm going to bring Julianne back in, who's been handling things in the background. She's in time with her hat. And so there's still questions in the queue, but it is getting well past our time now. So we'll just have to bring you back on, Andy, in a few weeks and answer some more questions. So, Andy, thank you for taking the time out to share with the crew and giving some in-person answers. It's just nice to have a face to the name sometimes.
Yeah, thanks for having me. And if you guys have any questions, make sure to reach out to us. I also write the technical production updates and things like that. So if you want to hear more about what we're working on, I also make videos to kind of like recap everything that's going on. We have live streams on our on our YouTube channel as well, talking about answering a lot of these questions. So lots of places for to learn from there.
Okay. All right. Well, with that, we will see you next week. Again, links are in the description for everything we've talked about. And give Julianne some love for hanging in there in the background. And we will talk to you again next week. We got Hamilton coming in 2 weeks, 3 weeks.
Hold on. Let me get my handy little planner here.
3 weeks. You'll get an email if you're on the CNC Insiders list. So
let's see. 1, 2, 3. 3 weeks. Yeah.
3 weeks.
5th of June. June 5th.
All right, y'all. And we'll get Andy back on because there are a lot of questions still out there. So all right. See you next week. I hope you enjoyed this dialogue with Andy Lee from CNC Labs and that it gave you a broader understanding of the CNC industry and maybe helped you figure out what CNC machine you want, or maybe if you want to upgrade to a machine. And if you haven't already, then please take a minute to give this video a thumbs up, a comment down below. And if there's other people you'd like me to be interviewing, then put their names down in the comments and I will go track them down and we will get them on an interview. Have a great day. Better tomorrow, and happy CNC. IDC Woodcraft.com